Good afternoon. Looks like we can go ahead and get things started here. Welcome everyone. Thank you for coming. This is Math Taught Visually, Instructional Concepts and Conversations That Work. This is a free webinar centered around the brand new, just released 2025 second edition of Eyes on Math, A Visual Approach to Teaching Math Concepts by Marian Small. My name is Emily. I work for the publisher of Eyes on Math, Teachers College Press. So on behalf of Teachers College Press, welcome and thank you so much for being here today. We're so thrilled to have here with us the author, Marian Small, to take us through her work and explain why this approach that she'll describe and deals with in the book is so effective at clarifying math concepts that students find difficult. Marian is an international professional developer, conference speaker, best-selling author. She's the former Dean of Education at the University of New Brunswick and a longtime professor of mathematics education. She maintains a website, which I'll be putting in the chat, about her work and her professional development. And she's authored many, many books on math education and understands this space as well as anyone. So Marian, thank you so much for being here. We are grateful to have you here to share your work and your expertise. Eyes on Math, as I mentioned, it's a second edition. It's a teaching resource. It's been extensively updated and expanded. So if you are at all familiar with the first edition, there's still a lot you can learn today from the changes that have been made. The new edition is a full color book with over 100 engaging full color visuals illustrated by Amy Lynn. The illustrations are accompanied by explanations of how they can be used to stimulate mathematics learning, to explain mathematical concepts, and to assess students' mathematical understanding grades K to 8. So the book, as I mentioned, it just came out this year in January. So it's out now, it's shipping, it's available immediately as a teaching resource, perfect for K to 8 math teachers, curriculum leaders, math coaches, school administrators, anyone who's searching for rigorous field-tested methods for deepening students' mathematical understanding using visuals. For a very limited time and exclusively for the attendees of this event, we're offering a 20% discount on the book. I'm going to be putting the details of that in the chat in just a moment. You'll also find it in your follow-up email to this event, so look out closely for that. And don't miss this opportunity to get a great discount on a great resource for math educators. We're offering the promo code at our website, tcpress.com, which serves shoppers in the US. If, like Marian, you're in Canada, you can use the exact same code at our Canadian distributor's website. Again, all of this is going in the chat. There'll be shopping alternatives for Canada and the US. The same discount is extended to both. We know students across the country are continuing to struggle with math, which makes user-friendly resources that can help clarify concepts for those students so valuable. That's exactly what this book does, so please take advantage of that 20% off. If you represent a district or are interested in a bulk purchase for teacher professional learning, we can help you with bulk discounts as well. So just get in touch. We'd be delighted to tell you more about the book and what it can do for the schools and the districts that you teach in. As I mentioned a moment ago, I'll be sending you a follow-up email to remind you of that discount information. That email will also include the recording of this event, so you can review it at your leisure. Please feel free to share it with anyone who wasn't able to join us today. If you have any questions while Dr. Small is speaking, go ahead and put those in the chat. I'll be monitoring that throughout, and we will return to them for a Q&A at the end of the hour. So go ahead and ask your questions as you have them, and we'll circle back to those a little bit later. And last but not least, I want to point out that this isn't a standalone event, but one of a series of math webinars that TC Press is holding this spring. We're aiming to bring you lots of resources for supporting math instruction all through K-12. We're very excited about the other webinars that are coming up. In February, we hosted an event on PBI in secondary math classrooms. The recording of that is already available if you missed it. Next up in April, we have a webinar on teaching algebra, another later in the season on working with elementary age learners, and another surprise webinar that we hope to be able to announce very soon. All free events all this spring. We'll also be launching a free newsletter for math educators this spring. So lots of exciting things going on concerning our math education resources. I'm going to put all this in the chat once again, so don't worry about remembering everything I've said. Please just look in the chat and remember to check us out, see what we have to offer at tcpress.com. And with that, I'm going to turn it over to our presenter. Please welcome Marian.
Thank you. Okay, so I am just going to take a second to share my screen and make it look a little nicer, and then we'll talk. And so I'm hoping that I can give you a feel, not only for what's in the resource, but sort of the background and why we're doing what we're doing. As Emily told you, the name is Eyes on Math, and this is the second edition. Now, the first edition has been out for quite a few years. And one of the issues is why would you change it? And one of the things is that things change and you think about new ideas and you want to incorporate those new ideas. So I'm going to talk to you, in case you are familiar with the first edition, with what's different about it, but then I'll go into detail in each of those areas. So the focus still is on the power of visuals in math instruction. And we often talk about children using manipulatives, and I think the concrete really does make an important difference. But I actually believe that it is the visual that is almost the key. That often we talk about moving from um, concrete to visual or pictorial to symbolic. I actually am starting to believe that pictorial or visual is kind of where we want to go. It's not so much symbolic, that the visual really explains the math to kids in a really powerful way. And I hope you'll see what I mean as we go through today. One of the things that was added to the first edition, which dealt a lot with explaining concepts visually, are examples of what we commonly call notice and wonder at various grade levels, because in a notice and wonder, we present a visual and ask students what they notice and wonder and pick up on their ideas to go and do some math. And we've also provided more examples of how you can assess students meaningfully by asking them to create the visuals to show that they understand ideas. And I'm going to show you several examples of that. But some of the work I've been focusing on lately has to do with how do you find out if students really understand something. And I'm learning that one of the ways I can find out best is to ask them to create visuals to show me an idea. And I'm going to show you lots of examples of that for you to see. We'll look at examples at different grade levels from K to 8. Now, first, I'm going to talk about what I see as the power of visualization in learning more generally. We all know that we'd rather kind of use our iPads or digital technology than kind of read something. We like the images, we like the motion, we like to see things. As a society, we've kind of moved in that direction. Even when we have wonderful books, we like to turn them into movies because we kind of like to see it. So somehow appeals to us kind of as a society. But I think using visuals enhances the learning process as well. It leads to greater engagement, and that's part of our attraction to the visual, and that leads to engagement. I also am convinced it leads to better memory of material that you've learned because you have a picture in your mind that you can kind of go back to and you can like see it in your mind and it helps you remember things. And many teachers talk to me about how kids seem to forget so much stuff in math. And so it becomes important to find ways to help them remember. I feel that these visuals are powerful tools in every domain in math, not just number, but also algebra and pattern and data and measurement. And so I'll be trying to show you examples in those various domains. So I'm going to start by showing you some of our notice and wonder examples. And if I were with you live, we would probably play this a little differently, but maybe we can do a little bit of it here. I'll kind of open the chat so that if you want to type something in, I'll be watching it at the same time. This might be something I present to kids, maybe they're in the primary grades, and ask them what they notice and what they wonder about what they're seeing. So pretend you are a 7-year-old, and I asked you what you notice and wonder. Maybe one or two of you can type something in about what you notice and wonder. So you're looking at these things. Some of you may recognize that these are what are often called Cuisenaire rods, although you don't need to know that. Others of you might not know that. So opposites, beautiful. And so I would be saying to Janice, like, what do you mean? If you were a student, what do you mean by opposites? Now, of course, I know what you mean, but my job is to get you to communicate more. And so I can see she sees white and blue with the white on top on the left, but with the white on bottom on the right. I noticed you can make two congruent parts by cutting the rectangle in half. So I'd be asking her, what does she mean by congruent? And which way should I cut it? Someone says they're the same on the top as on the bottom. So I might say to that student, like, what do you mean by it's the same? Someone says, I noticed there's a decreasing pattern on the bottom that look like stair steps, which is fantastic. And so somebody else will say, but like the orange one kind of ruins the steps. And all of this leads to such engaging conversations. And so you've used language like congruence. You used language, Jenna used a language like fractions. Somebody said decreasing patterns. And so my job as a teacher is to pick up on some of, not all of those things you said, and build my next activities around those things. And I can pretty much anticipate what some of those things will be. So I'm going to be kind of ready to go do that with the next stuff. So do you see how safe this is for kids? There's nothing wrong. You just say what you notice. And different kids might have wondered, like, how come the certain ones are certain colors, or why are there oranges on the left and right but not on the top or bottom? And so all of this gets kids talking about math, and then your job as teachers is to pick up on some of those things and broaden their understanding of those things. So partly I'm finding out what you know, partly I'm leading into a bigger lesson. Here's a different example that Amy drew for this particular version. So you're looking at a bunch of strawberries, and we ask kids what they notice and what they wonder. So let's try one more time. What is something you notice about the strawberries, and what are some things you wonder about? There are definitely missing berries. So there are like 4 holes in the berries. Like, why are there holes? That's a totally reasonable question. I wonder why there are gaps in the rows. Same idea said a different way, which is great. The berries form the number 88. Oh, that is so cool. So maybe nobody noticed that until Harry says that. And then, yeah, I kind of do see 88. And so we get to kind of look at, could part of the berries show you a different number? And that's a possibility. Some kids might wonder why they're sort of like pinkish and not redder, because often strawberries are red. And so that's probably going to happen. And then, though it's not mathematical, you're still engaging the student in having conversations in a math class. And I think that's great. Somebody notices a pattern of 6, then 4, then 6, then 4, then 6. So you could say, well, if there were more rows, how many do you think would be next? Or how many would you think would be next? Each berry has 6 leaves. Now, do berries usually have 6 leaves? And now kids are going to go find some berries and find out if they really do have 6 leaves. Do all berries have the same number of leaves, or don't they? And so we get into interesting discussions about the world. But we can also say, like, how would we count the total number of berries? Does anybody know how many there are? And then somebody who noticed the 64646 might use that information to tell me how many berries. Other kids might notice that there are 5 rows of 6 berries, but there are 4 missing. So maybe I could use that information to figure out how many. So we get possibilities of multiplication. We have possibilities of addition. We have possibilities of talking about patterns. And a teacher could choose to go in any one of those directions, depending on how the kids respond and what they seem kind of most interested in. Here's an example where we have something very simple for younger kids, where we're looking at bracelets and we're asking kids what they might notice and wonder. There are kids who are going to notice non-mathematical things. Like someone will notice there's like string hanging out of the left bracelet, but not the right bracelet. And our job is not to dismiss that. Our job is to encourage that. So kids feel very secure saying all the different things they do. That's a way of engaging kids who are timid about not saying the right thing. And at the same time, we're going to pick up on some of the more mathematical ones as we do more. Maybe some kids will notice that there seems to be color patterns in one bracelet, but are there patterns in both bracelets? And then we get to talk about what we mean by patterns. Someone might wonder if the bracelets are the same sizes. So if you kind of look like, would they fit the same size wrist? And so kids could go into directions that talk about measurement. They might go into directions that talk about patterns. They might count how many beads are on each one. They might wonder if the beads are the same size. So all of these are examples for younger kids. Here's one we have for kids who are kind of more in the middle elementary grades. And so we're looking here at this quilt that Amy created, and we're asking them what they notice about the quilt. And so probably they notice that there are lots of triangles in the picture. And then I might say, well, is it only triangles, or do you see other shapes too? And different kids could talk about the shapes they see. A lot of kids will notice that there are those tiny little blue squares, as well as some squares that are kind of in the middle of each segment of the quilt. We could talk about how many triangles they see. We could talk about how many squares they see. We can talk about whether they see anything except little squares, or are there big squares too. So notice that they might realize that each segment is a big square, but inside there are little squares. So we can get them noticing shapes. We can notice shapes in different orientations. We can count. If I said to you, how many triangles do you see? There's lots of work that we could do to get kids kind of moving using this particular notice and wonder. Here's again one for little kids. You and I all know that this is an egg carton. Some kids will notice that it only holds 10 eggs, and most egg cartons, like in my house, hold 12 eggs. So is this like a normal egg carton, or do they have different sizes in like different places? And we might talk about that. Maybe kids will wonder why there are 3 eggs missing. Like, what did they use those eggs for? Maybe they'll wonder why those 3 eggs are kind of scattered, and not like all together. Like, don't you kind of take them out next to each other, or do people do that kind of thing? You might ask how many eggs there used to be. You might ask how many eggs there are now. You might ask how many eggs are missing. So there's lots of those kinds of questions you could ask. Here's one I'm going to ask you about. What is something that you notice, and what is something you wonder about all these pastries? I wonder how much they cost. That is a great question. So do you think, and I might ask kids, do you think that if something is a smaller thing, it'll cost less? So like, will those things on the bottom cost less than the cake because the cake is like bigger? Or if you have something that has like more decorations on it, does it cost more? Or if you something has more fruit on it, does it cost more? How many calories do they all add up to? Probably way too many, but that would be an interesting question. Like, which ones do you think have the most calories? Is it about their size, or is it something else that tells you how many calories they have? What would a normal cake have for calories? What would a normal croissant have for calories? Oh, colorful patterns. So they might notice the patterns in the decorations. So if you look at those little chocolate guys in the bottom, there are these pretty little things sticking out, forming a pattern. I wonder which is the most popular, because I noticed there are more of some items than others. A great question. So if there's more, do they have more because they know people want to buy it? Or do people buy multiples of certain things, but only one of other things? So, what I like about these notice and wonders is that I think part of our mission as teachers is to help kids learn about the world. But at the same time, we want to do the mathematics. So I think you can see from some of the different questions you've raised that part of it is learning about the world, and part of it is learning about the mathematics. And I think both of those are in our bailiwicks. This is one that's interesting. Some of you may know this is Wimbledon, but you don't have to. But some kids may have never seen tennis and have no idea what it is. And they might wonder, like, why is there this like big green grass in the middle? And so people have to talk about maybe a kid's never seen that some people play tennis on grass. And so you could talk about that. You might wonder how many people are in the stands. Like, do you think it's hundreds? Do you think it's thousands? How could you estimate how many people are in the stands? Because it's pretty hard to count every one of them. And we don't even see everyone there. So how would we get an estimate of how many people are really there? They might wonder about the court and what fraction of the field the court takes up. Like, is the court actually half the grassy area or more than half or whatever? So we could do with some fraction ideas. They might wonder about the pattern in the top and like how big those things are really, because this is obviously a picture and they're a lot bigger than they look here. So how big are these things really? How big do you think that court really is? Does looking at the people help you figure out how big the court might be? So all of those things are kinds of questions about scale, about ratio, about proportion that kids might be thinking about. Here's another one we have where obviously someone is pouring juice for something. And so so different questions could come up. Kids could count how many have already been poured. They could count, do you have more than half the glasses been filled or less than half the glasses? There are some glasses that seem to be missing from the photo. Do you think it's nice lines, or do you think it kind of does sort of cut off and it's only the glasses that we see? We could wonder about how many glasses of juice you could fill with one container. Like, was that all from one container, or is he on a second container? And so we might go into liquid volume and measurements and figure out how big pitchers usually are, how much glasses usually hold, how many of this make that. So there's all kinds, again, of multiplicative questions, division questions, measurement questions that this could lead to. But for a kid who's not comfortable with all that stuff, he can just like wonder if it's orange juice or apricot juice. And what I think is so important is that we're inviting that of kids. Um, and that we're trying to tell them we're interested in their ideas. We're not just asking them to parrot back our ideas. Here, I think this is the last notice and wonder I'm showing you. This is one, obviously, some people are playing basketball. There's all kinds of questions. So what do you think students would notice or wonder about with this basketball picture? How tall are the players? Beautiful. So are these like really tall kids or regular kids? Is the ball going up or down? What a cool question. Like, can you tell if the ball is going up or down? Which jumps the highest? Okay, so like if you have different players, do taller players jump higher than shorter players? Could be a question. How high can a normal teenage kid jump? How high is the net? How far from the net is the ball? All of those are questions that you could ask that might be interesting to lots of different kids. Other kids, I'm going to tell you, are asking, like, why is one of the kids bandaged up on his leg? And again, I'm just going to say one more time, we're welcoming that question too. So part of what's new in Eyes on Math are these sections for K to 2, for 3 to 5, and for 6 to 8 with these visuals. I haven't shown you all the notice and wonders, but I've shown you a number of them with suggestions of what kids might do and how you might follow them up. Now, the biggest part of the book remains what it used to be in the first edition, where we're going to use, I call them provocative, not like in the bad way, but things that make you kind of curious or you're not so sure about visuals to initiate conversations about mathematical concepts. And I think the more it's not clear cut, the more interesting the conversations are. So here are some examples. This was in the original version as well. This is for little people, and you see that there's a bunch of ants on a picnic a blanket. And the question is, which ants did Megan already count? How high will she go to count all of the ants? So one of the things we want kids to know is even though we as grown-ups figure that the ants she counted are probably the six that are already off the blanket, maybe that's not true at all. We can count in any way we want. And so this engenders that discussion. Maybe she was counting the six at the bottom left. Like we don't know, even though lots of us think she was counting the six at the top. When I ask how high will she go to count all the ants, it's just a way to talk about what's a good way for you to figure out how many ants there are. Are you going to count them in a particular order? What order would you choose? Like, why would you choose that order? And so it's just a nice discussion about options when we're counting. This is one of my favorite pictures in the entire book. Um, does this picture show, and it says a single multiplication. So let me why I said like that. When I first wrote the book, I said, does this show a multiplication? And what people were telling me is there were this many fours plus this many twos. I'm wondering if you see a single multiplication, just something times something. So does anyone see a single multiplication, or do you only see like a combo thing, a multiplication plus some more? So what would your response be? Do you see a single or do you see not a single? I see both. Okay, so I think we can, if you circle groups of two, then yes, beautiful. And so this is what I mean when I use the word provocative, that some people will say, I see this, but other people will say, no, I see this. And I think that makes for a more rich conversation and for kids to see flexibility. And part of our goal in teaching math is to teach kids how to think flexibly. So I believe, and I've actually done this with kids, so I know that some kids will say it's not one multiplication. There are this many times four plus this many times two, and that's all there is. I've also had kids do what Jenna said that she saw. By the way, do you notice that I had four icebergs with two on them? The reason I chose an even number of icebergs because you could take two of the twos and put them together to make a four, and the other two of the twos and put them together and make a four. And now you do see only fours. So you can write something times four. So it feels like a single multiplication. But other kids tell me, well, why don't you split the icebergs with four on them and make them all twos? So you could see a bunch of twos. And then other kids will tell me, I think there's 36, if I remember correctly, 1, 2, 3, 4, 5, 6, 7, 32, whatever number of penguins there are. And they say there's that many times one. And they are right as well. And so then the question becomes, is like everything a multiplication? Because you always could write times one. And that's an interesting debate. And I think those are healthy kinds of discussions to have with kids. So this kind of visual leads to that. If I had just shown only icebergs with four, there's not much discussion. Everybody just says, yeah, it's a multiplication times four. And it's not as interesting as when you have this, what I called provocative. Okay. We have a top and a bottom here. And the question is, which section has more marbles? And are you sure? So the are you sure is like important here. So notice that on the top, I have bags of 100 that are marked, but I have an unmarked bag. And at the bottom, there are bags that are marked 100, and I have an unmarked bag. So the question is, since those bags aren't marked, can you still be sure if the top or the bottom has more marbles? Now, clearly, the math idea we're getting at is it kind of looks like the unmarked bags are less than 100. Visually, it looks that way. And if they're less than 100, it's like, who cares about them? All we care about is there's 400s versus 300s. So essentially, we're talking about a really important place value idea that when we're comparing three-digit numbers, the hundreds is kind of what we care about the most. And this is a visual to kind of lead to that particular discussion. Here's one that was in a different grade. And so there's two little kids looking at a puddle, and one kid says the puddle is 10 steps wide, and the other kid says the puddle is 12 steps wide. And the question is, who is right? Now, the truth is, we have no clue who is right because the puddle's like a picture, it's not even there. I want kids to know, well, unless we know the size of the steps, we can't really be sure. Yes, Beth, you will receiving a recording. And so and it's possible that it's 10 of somebody's steps, but it's 12 of somebody else's steps. And so we're talking about how non-standard measurement works. We're talking about the idea that a certain object can be measured and we come up with two different numbers depending on the unit that we use. We're coming up with the idea that the person with the smaller step will have the bigger number, and the person with the bigger step will have the smaller number. And so we're going to get to talk about all that. So this little picture kind of leads to a big discussion. Um, this one's an interesting one. This is a line of elephants, obviously, and the question is, which elephant is fourth? And I think for a lot of kids, it'll be a slam dunk. The elephants are all kind of facing toward the right. And so it's going to be that pink elephant that's sort of on the right. That is the fourth. But I'm hoping someone would say, no, I think it's the purple striped elephant that's more on the left. That's the fourth. And then we talk about how ordinal numbers are based on position, whereas cardinal numbers are not based on position. And we get to see that the only way you know which is fourth is making a decision about where we start. And if I were on the left, I might decide the fourth is the purple guy, but if I were on the right, I might decide the fourth is the pink guy. And so we're getting into a mathematical discussion about what ordinal numbers are about. This is a particular question where I ask, are all of these showing halves or not, or only some of them showing halves? And so some of them are pretty clear. So a lot of kids will look at the middle left and say that's definitely half. A lot of kids will look at the top left and see half. There are kids who will be comfortable with the half on the bottom right. There'll be kids less comfortable with that because for them, lines of symmetry need to be vertical and horizontal. Other kids will say that the one on the top right is half, but other kids will say it's not half. It's two fourths. And then is that really the same as half? And so we can get into that discussion. The one on the bottom left is the most interesting. Like, do you think that purple is actually half of that or not? How would we figure it out? Like, what strategies could we use? And we'll get kids to talk about that. So we're getting them to see that there's lots of ways to show halves, and some of them are more obvious than others. Are they always about symmetry? Do they always have to be about symmetry? So those are interesting discussions. This is a picture that has to do with what we call the distributive property of multiplication over addition. We want kids to know that one of the ways you can figure out 7 times 6 is to break up the 6 into 4 and 2 and do 7 4s and 7 2s. And this picture is designed to help kids see that. So how does the picture help you see that there are lots of ways to figure out 7 times 6? One way is obvious because I put a great big white space between 4 carrots and 2 carrots. But maybe a kid could understand you could take that bunny in the middle and his carrots and move it a little bit, and you'd see 7 3s and 7 3s. Or maybe a kid will figure out what you could do is like take some rows and push them down a little bit. So you could break up the first number or you could break up the second number. So it's a way of talking about the distributive property. Um, Probability is an interesting topic. There's some research that talks about how probability has issues that other domains in math don't have. Partly it's for cultural reasons, partly it's because so much of math is predictable and you can tell exactly what's going to happen and why it's going to happen. And probability is about random. And so you can't be sure what's going to happen. And that really bothers kids because the whole premise of math is that everything's predictable. So here is a coin that you flipped. And clearly you already got 7 heads. And the question is, what will happen next? And how sure are you? So I've used this in front of kids, and some kids are absolutely sure the next one will be tails because there are already too many heads and it's sort of like tails turn. Other kids are equally sure it's going to be heads because obviously there's something wrong with this coin and it's only going to give you heads. And other kids will realize like there's no way to be sure this could have like really happened with a real coin. And so it gives you a really great opportunity to talk about probability, how you can never on a random event predict what's going to happen next. You can only talk about like in the long runs. And that's a really important probability idea that you want to talk to kids about. So this one I feel is a nice one. The reason it's provocative is because like you can't really even believe you got 7 heads. And so it's kind of leads to an interesting discussion. I think if I had put like 4 heads and 4 tails and said what will happen next, it wouldn't be as interesting a discussion because everyone will just say, well, it could go either way. This one is you're going to have kids who are passionate that it's going to be one versus the other, and it makes for a more engaging conversation. This is a picture I've used with young kids and asked them if they see addition or if they see subtraction or if they see both. And my experience has been that almost all kids say they see addition, but saying they see subtraction is a mixed bag. There are kids who see no subtraction. There are kids who see some subtractions, but not other subtractions. And what they see is really interesting. My goal mathematically as a teacher is for kids to understand it is impossible to see addition without subtraction or subtraction without addition. They are a package deal. And so I want a kid to see, yes, there are 5 plus 8, but so there is a plus, but I could also see 13 minus 5 if I'm saying if there's 13 things and 5 are helicopters, how many can be boats? I also see 13 minus 8 equals 5. If there are 13 things and 8 of them are boats, how many could be helicopters? And there's also the comparison of boats to helicopters, 8 minus 5. So I actually believe I see 2 additions and maybe others if you kind of split up the picture more. And I see at least 3 subtractions in this picture. So I think my message for kids is that you can't see addition without seeing subtraction and vice versa. And I think that's an important message. One of the things we want kids to know is that when you have shapes, the shapes can have many different names. And so I want to know that that purple thing could be called a square or a quadrilateral or a rectangle or a parallelogram or a polygon. There's like lots of names. We kind of relate that idea to how a person can have a lot of different names. So somebody calls me mom, but somebody else calls me auntie something, and somebody else calls me with a different name. And so the idea is like helping kids see it's not shocking that different people call a shape different names sometimes because that's how we do people too. So it's trying to draw a relationship. Here's something about equations. How are the equations for the 2 balances different? What I want students to see is on the top equation, I have what I'm going to call solving for an unknown. There's one solution. If 2 X bags balance this many cubes, there have to be this many cubes in each of the X bags. There's only one value that'll make it work. But if you look at the bottom picture, we have an equation that has many, many solutions. 2x plus 2 plus 2 is equal to 2x plus 4. That'll be true no matter how many are in the bags. And so we want students to see equations can have one solution. We call that an unknown. Equations can have many solutions. This is one about division. I want kids to look at the fish in the bowl at the top and then see how the fish were sorted by color at the bottoms and ask them what division they see. So some kids will see 24 shared into 4 groups. So 24 divided by 4 is 6 because then there's 6 in each group. Other kids will see 24 divided by 6 is 4. They're saying there's 24 fish. If I group them in sixes, how many do I need? Well, I need 4. And so we want students to see that there's different meanings of division in the same situation. Here's one where I ask kids to describe the cabinet using fractions, and they can use whatever fractions they want. So maybe they'll see that there's 8 drawers and 2 of the drawers are open. So they'll say, I see 2 ace. Maybe they say, I see 6 ace. Those are the closed drawers. Maybe kids will say, well, I see 1/4 because one of the 4 sets of 2 drawers is open. And so they'll see that 2/8 is the same as 1/4. Maybe some kids will see, I see 8 ace because there are 8 drawers and that's all of them. So different kids have different things that they can talk about. We can talk about equivalent fractions. We can talk about looking at what's there versus what's not there, that all of those happen in a fraction situation. I particularly like this one, which grid or grids show percent. There are kids who believe that the only one that shows percent is the left one, because if you see percent, it's got to be 10 tens. Like it has to be 100 things. So that's the only guy that shows percent. But other kids will say, well, the bottom right shows me 100%. Like I don't even care how much is there. 100% is everything and it's everything. And other kids will even say, well, I think even the top right shows 25% because 25% is the same as a quarter. So it's a way to have a discussion about, can percent be based when there isn't, can you talk about percent when there isn't 100, or does there have to be 100? And I think that's a really important discussion to have with kids because some of them are really mixed up about that. Here are 3 children. We say one of them is 7/8 the height of another. One of them is 1 1/3 times the height of another. Who is who? And so I'm finding out if kids really understand what it means to be 7/8 of something. What does it mean to be 1 1/3 of something? Do you know that means you're bigger, but not like a whole lot bigger? Do you understand that 7/8 is not quite as much, but it's like almost? And we're seeing if they really understand what these, when you use fractions as comparisons, do they understand that? This is one that talks about uh, subtraction of integers or directed distances. My question is, do these arrows show addition or subtraction? What do you notice each time? Most kids will tell me they see addition because you would go starting at the letter so many forward to get to whatever the answer is. And so they see addition. But this harks back to the grade 1 one. There is also subtraction. So if you look at A, you are also looking at 11 minus 0 because 11 minus 0 means how far ahead of 0 is 11. If you look at D, you're also looking at 6 minus -5 because 6 minus -5 means how far ahead of -5 is 6. So I'm talking about, again, the relationship between addition and subtraction. Here I'm talking about what we call the mean, or the measure of central tendency that we call the mean, what we used to call an average. And I want kids to see that what a mean is means that if you have things that aren't already balanced, you find a way to balance them out. And once you balance them out, that value is the mean. So what I did is I moved cubes from the red and orange to the blue and green. And now that they're all the same height, that height is the mean. So it would go with a lesson where you focused on how that mean is calculated, but it helps them see what it means visually. I'm picking and choosing because I know it's getting late. So I wanted to show you this part too. I wanted you to see the parts where I'm getting kids to show their understanding visually as well. And I have a few examples that I wanted to make sure you saw. The question for the kids is, how might you show why 3 plus 8 has to be the same as 2 plus 9. You can't tell me they're both 11. Your picture has to show it. Now, we actually went out to kids and got them to draw pictures, and we prettied them up a little because their apples were like uglier. But this is what it looked like. They understand that if you had 3 and 8, all you had to do was move one apple from the 3 pile over to the 8 pile, and now you'd have 2 and 9. If a kid understands that, I like totally get it that they understand the idea of what is actually called the associative property by my asking for a picture. If I hadn't asked for a picture, all any kid I know would say is 11 equals 11. They wouldn't be showing me why you can make that move. All they'd be showing me is that you can make that move, and I don't feel that that's as good. And so that's why I asked for the visual. I asked how might you make it easy to see how much more 10 is than 3. And this is what one kid did for us. They were looking at 10, they were looking at 3. They decided the way that was easy for them was to get to 5 and then do the rest of it. So I can see that it's 2 and 5 more, so that's 7. So that was a student's choice. Now, a different student might make a different choice. And I think that's great. Like, we want kids to understand that in math, people see things differently, and one person likes this way and one person likes that way, and it's all good. How might you make it easy to see that 24 divided by 3 is the same as 48 divided by 6? Now, I'll tell you what the kid who did this. Now, again, their ducks were not as cute as our ducks, I will admit that. But they did this kind of idea. So this is what they said. If you had 48 ducks and you were making 6 equal rows, like I did here, what you could do is take the first 24 and make 3 rows, and the other 24 and make 3 rows. And so really finding out how many ducks you need in a row is the same whether it's 48 in 6 rows or 24 in 3 rows. So we want kids to see why when you're dividing, you can multiply both factors by the same amount and not change the quotient. Here's one where we ask kids, how might you make it easy to see why 4/3 divided by 1/5 is 20/3? So what would you do so I could see that? So you can't just do the calculation, I need a visual. So a kid is showing me that they know that what I'm really asking them is how many fifths fit into 4/3. So they showed me 4/3 and they showed me fifths. Now, I still don't see the 20/3. And that's why they had to do another bit. So here's where it went next. They actually changed their fifths to 15ths. They changed their thirds to 15ths. And now when I'm counting how many sets of 5/15ths I can get into 20/15ths, they can see, oh, it's how many threes fit in 20, and that's what 20/3 is. So I'm really seeing if they understand that what division of fractions means is how many of the second fraction fits in the first fraction, and that one way you can divide fractions is get a common denominator and just take the ratio of the numerators. How might you make it easy to see why 4 minus -9 is 13? I want kids to understand that 4 minus -9 means what do you have to add to -9 to get up to 4? And there I see the bunny doing it. He goes 9 and 4 more, and that's why we end up adding 9 and 4. So what I'm hoping is that these ideas will provoke other similar ones for you. I've given you lots. You've only seen some of them here. There are hundreds in the resource that you can borrow. What's lovely is TCP has made it possible for you to download those visuals and present them. What I've provided in the resource are questions that you ask for follow-up and ideas about what kinds of things you want to make sure you bring out. And so there's lots of extension questions and lots of questions that help you know what to do as kids respond to you and what you're doing with the visuals. So I am going to stop sharing and leave the opportunity for any questions you might want to raise.
That was so wonderful. So thank you so much for the presentation. And while we're waiting for some people to put their questions in the chat, we actually collected a few questions at registration from some of our attendees. So
Cool.
I'll just get us started with a couple of those.
Okay.
Um, One of the great things about this method is that it can help teachers working with students who have low reading ability, like
Yep.
special education students or English language learners.
Mhm.
Can you talk a little bit about what it's like to work with this
Absolutely.
population?
Yeah, absolutely. So I actually do lots of resources, and some of them have many words in them. It is my belief that the math that we want to teach kids requires words. But the words are hard for lots of kids who are second language learners or who have learning disabilities of various sorts. And so for me, one of the things I want teachers to know is that we're going to use visuals and gestures and all those kinds of things to clarify these ideas for kids. What we don't want to do is say, well, if a kid is struggling with language, I'll just give them calculations to do because they can't read any words. We need to have these richer conversations, but the only way I feel we can access those kids is using things like gestures and whatever, but also visuals that stimulate the learning. And so most of the pictures you saw, like remember the puddle, like a kid knows what a puddle is, like it's not hard to access. Um, any others that you had, Emily?
Let's see. We had a couple of questions. Um, we had a couple of questions pertaining to like teaching math virtually, which I hope I'm understanding the questions correctly because that's not something you do as often with
Yeah,
kids
yeah.
in this age group. I think at least some of those questions were pertaining to teacher educators,
Okay.
in pre-service teachers. But I think we had at least one person in at registration who perhaps was teaching children virtually. Um, we saw through your presentation that a lot of these visuals work very well in a virtual
Yeah,
environment.
yeah,
Do you
yeah.
have any other specific advice about that?
I think one of the things we learned during COVID was that even if you're teaching virtually, we still can't be heavy text. We still need lots of visuals, and we also need lots of conversation. So the teachers I find who are most successful virtually are ones who have lots of breakouts with small groups. So it's not about like you presenting visually a big thing. What we want is for you to present an idea, but then just talk to a small group here or a small group here or a small group here while other kids are working on something else, because it's just too difficult to engage in conversation virtually if you have too many people at the
Mhm.
same time. So I think that's one of the things we learned. Um, how do we educate teachers to develop a deeper mathematical understanding of knowledge? That's why I wrote so many words with each of the pictures that I presented in the book. I know that teachers don't always have that background and don't always have that. So I mentioned during one example that I was doing the associative property. I've done this long enough to know that many teachers don't even know what I'm talking about. What is it and how is that the associative property anyway? Like that's not what I thought it was. And so my job in the resource was to actually provide that background for teachers. Like this is what people call the associative property, but it's real here. It's not just like a bunch of symbols that you see on a page. It's to try to make it real for you. So my work was to provide that deeper understanding for teachers, knowing that they don't always have it. The resources that Marian is referring, like I'm not even sure which ones I'm referring to. I've written lots of stuff, and if you Google me, you can find them. But there are many, like one of the resources I've been working on a lot lately is called "Do They Really Understand?" And I'm really focusing on how do you ask questions to have kids like use visuals to show their understanding of something. So something like "Do they really understand?" is one of those examples. Or another resource really focuses on how do teachers learn the underlying mathematics. So if you Google me, you can probably find most of them.
Maybe we can go to one more from registration while we're waiting
Sure.
for some people to put some more things in the chat. This participant was interested in learning about techniques to make math more real for the students,
Mhm.
which I can totally see in some of the problems you're presenting. Is that can you talk about that a little bit? I
Yeah,
mean,
I
when
can.
you're not making a
Yeah.
concept totally abstract for a kid.
Absolutely. So I actually have probably a unique and different opinion than some people on this. There are people who believe that the purpose of math is as a tool to solve real world problems. And so they would feel the need for context all the time. I actually have a different view of math. I see math as an art form. I always have. It's like a puzzle, and it's like art for me. It's like this is a way of like looking at things, and it's unique, and there's patterns, and there's relationships. And so I look at it that way. And so even though there's part of me that does the context thing, because that is valuable, there's also part of me that wants to appeal to kids who want to like, how does that work? And figure it out. And oh, does that always work? Like, so for me, it doesn't always have to be contextual. And so when I had the penguins being the multiplication, like I know they were penguins, but it wasn't anything about penguins really. It was really completely about the math. And I felt no guilt making it completely about the math. Sometimes we put in context, like I've seen problems for grade 3 kids about making patios. Well, no 8-year-old I know cares about patios. And so for me, the context isn't real. I feel the reality for kids is playing games and figuring out life. And so I want to kind of play mathematical games with them. And for me, that seems like more contextual. That's at their level.
Great. Great. Maybe we have time for one or two more. Um, this attendee asked, how can you plan the sequence of learning and support and support teachers with content knowledge? Now, you talked a little bit about how the resource supports
Mhm.
teachers with the background knowledge, but what about the sequence of learning and how you kind of build these into instruction?
It's interesting because I'm one of those people who doesn't believe there is a single learning trajectory that's right for all kids, that I believe that kids are different. And so there are ones that make no sense, like you need this idea before you do this idea. But I think there's more variety than people think. And I work with many different school districts, and in certain districts, they've just decided or decreed, like, we think this is the best way. And I don't think any of them are wrong. It's just that I think they're wrong if they think there's no other best way. So I, for example, know a teacher who teaches grade 6, or well, in the US, it would only be grade 7 where this would happen. Probability. In fact, I wrote a resource in the US and I made probability the first topic of instruction. And everybody looks at you like you're crazy, like who would do probability first? But in my world, getting kids kind of hooked into math and thinking it's fun and thinking it's interesting and kind of playing around with it is a really good thing to do when you first meet them. And so I think that's a great first topic because it's not like I want to review, do you forget this? And did you forget this? Did you forget this? I want to make math a happy place. Some people think you should start with measurement because it's hands-on. And while you're doing that hands-on stuff, you are also using numbers and finding out about numbers. You're also doing a little bit of geometry. And so I know people who always think you should start with measurement. I know people who think you should start with data because it's about the world and kids are interested in the world. So I don't think there's a right answer. I think there are things you can do that make no sense, but I think teachers when they have the ability to, I know sometimes they live in a system where they don't, but I think they should realize they have much more say in the way things happen and that different kids will respond differently. And maybe one way works for one kid or one class and another way works for another.
Yeah, yeah, that's just amazing. I mean, one of the final questions from the registrants at the that we received before the webinar um, was kind of asking about strategies that they could present to their college level pre-service teachers, and I was just struck by what you were saying about like how if a lot of what you're describing is based on teachers' experience in the classroom, and it would be so interesting to see how this can impact people when they're still in their pre-service
Yep.
teaching to start understanding what it might be like to work with students who see things very differently.
That's right. And to recognize, I think this is such a huge message for me that my message to teachers is your job is to listen to them, not make them listen to you.
That's great. And what a nice concise point to for us to end on because we are at our time here.
Okay,
Thank you so much for being here. Thank you for this presentation. It was just wonderful. Uh,
good.
Thank you to our audience for being here. You'll all receive a link to the recording. You'll receive info about that discount to purchase your own copy of Marian's book, of which these examples are only a small part. Um, so yeah, please please look out for those in your email. Follow up with us if you have any other questions about the resource. We really appreciate everyone's being here, and thank you again to Marian Small.
Okay.
All
Bye,
right,
everyone.
bye.